Now we will be learning about the knapsack problem. Consider we are given a bag with some capacity and also some items with values and weights. We have to fill the bag with the given items such that we get the maximum value from it, and also the total weight in the bag is less than or equal to the capacity of the bag. We will take another example of a thief who contains a bag which is having a capacity of say some W kilogram. So how can he fill the bag within this capacity and also obtaining the maximum possible gain? The answer is given by the knapsack problem. Now technically we will describe about the knapsack problem. Here we are given with n objects where each object I has a weight of Wi and a profit of Pi and a knapsack of capacity m. Now xi is a variable which is used to denote the unit of the object placed in the knapsack. Like if xi is 1, we are placing the whole object inside the knapsack. If xi is a fraction, we are keeping a part of it in the knapsack. So that is, if a fraction of xi is placed into the knapsack, then a profit of Pi xi is earned. Thus, the objective of this problem is to put the objects into a knapsack that maximizes the total profit without exceeding the capacity of the knapsack, that is m. Thus, the problem is to find a solution that maximizes sigma Pi xi, that is the profit subjected to sigma Wi xi less than or equal to m. That is, the weight in the knapsack should not exceed the capacity of the knapsack. Now we will consider an example for the knapsack problem. Here I have considered 3 objects and the capacity of the knapsack is 20. Now the first object has a weight of 18 and a profit of 25. The second object has a weight of 15 and a profit of 24. The third object having a weight of 10 and a profit of 15. Now these are some possible solutions. There can be more, but for convenience I have taken 4 solutions. Now consider the first solution where I have taken half of the first object, 1/3 of the second object and 1/4 of the third object, which will give me a total weight of 16.5, which is less than the capacity of the knapsack, so which is feasible, and it gives me a profit of 24.25. Now consider the second solution where I have taken 1 unit of the object 1 and 2/15 of the object 2 and nothing from object 3, which will give me a total weight of 20, which is also feasible since it is equal to the capacity of the knapsack, and the profit which I obtain is 28.2. Now consider the fourth solution where I have taken 1 full unit of second object and half of the third object. Here I will get a total weight of 20 and a profit of 31.5, and this is the optimal value. As we can observe, the profit of the fourth solution is the maximum, and so is the reason that it is chosen as the optimal value. Before examining the greedy strategy, let us make some obvious observations or lemmas. Lemma 1 is if sum of weights of all the objects is less than or equal to the capacity of the knapsack, then every object can be chosen into the knapsack. Let us assume that the sum of weights exceeds m, that is the capacity of the knapsack, so that xi cannot be 1. Lemma 2, since we are choosing fractional amount of an object, all the optimal solutions will fill the knapsack exactly. Let us try to find a method which can give the optimal solution for the knapsack problem. We can do it by selecting the object with highest profit, then the object with the next highest profit. If it's not fitting into the knapsack, we can choose the fraction of it and can be taken into the knapsack. So in this method we will take the object 1, the whole 1 full unit of object 1 since it is having the maximum profit, then 2/15 of the object 2 because a full unit of object 2 can't be included into the knapsack, but it will give us a profit of 28.2. So this strategy can't give us an optimal solution. Now we'll choose an object having the least weight, then the object with the next least weight, and so on. Even this idea too does not result into an optimal solution. For the above problem, in this idea, we take 1 unit of x3 and 2/3 unit of x2. Even this will give us a profit of 31, which is also not an optimal solution. Another idea is to balance between object weights and profit in making the selection. Here at each stage, we chose an object that has highest profit to weight ratio, that is Pi by Wi. This gives us the optimal solution. For the above problem, P1 by W1 equal to 1.38 and P2 by W2 equal to 1.6 and P3 by W3 equal to 1.5. So here we are choosing one full unit of object 2, half of object 3 and nothing from object 1, which will give us a profit of 31.5, and which is the optimal solution. The technique which gave the optimal solution for the knapsack problem requires a big O and time complexity. Here time required to sort the object is not included. Now we will take an example problem. The problem is to find the optimal solution to the knapsack, where the objects considered are 7 and the capacity is 15, and the profits and weights are given. Now we will see how to solve the problem. First we have to find the profit by weight ratio of all the given objects. Then we arrange the objects in the decreasing order of profit by weight ratio. Now we take a variable u and give it the value of the capacity of the knapsack, that is 15. Now consider the object with the highest P by W ratio, that is the fifth object. Now since the weight of the fifth object is less than the capacity of the knapsack, we add it to the knapsack. So since the weight of the fifth object is 1, after adding object 5 to the knapsack, the remaining weight in the knapsack is 14. Now we consider the next object, which is having the maximum P by W ratio, and it is the first object. So since the weight of the first object is less than the capacity of the knapsack, we can add one full unit of the object to the knapsack. After adding object 1, the remaining weight in the knapsack is 12. Continue the process. We will consider object 7, and since the weight of object 7 is less than the capacity of knapsack, one full unit of object 7 could be added to the knapsack. After adding object 7, the remaining weight in the knapsack is 2. The next object to be considered is object 2. Since the weight of object 2 is not less than the capacity of the knapsack, we add a fraction of the second object, so that the knapsack is full. Now for getting the profit, we add xi into pi, and finally the profit obtained is 55.33. Thank you.